Yeah, that's okay. No worries.
All right, let's start with your
Let me,
presentation now.
yeah, let's present. Okay, I hope you guys can see this one
Yeah,
here.
we can see it.
Correct?
Go ahead.
Okay, so this is just a preamble to the some of the few slides are going to be preamble, so it may be boring. You may have seen it several times, but this is how we basically see why the CXL is basically DRAM is getting slotted below the traditional DRAM. So we basically are saying, okay, how is the cost and the capacity is going to be tiered in between the DRAM, and there is a need for an expansion form factor which can give you the capacity as well as the latency tier below the standard locally attached DRAM. And that's the memory storage paradigm. I had to use this one all the time, my slide, before I go to the next slide. So how I see or how we see inside is basically everything is going to be basically the OS down the line is going to be basically aware, needs to be aware of the where the data is placed and the tiers are getting basically developed. So we know basically there is a high bandwidth memory on the chip, which is probably 64 gigabyte to 80 gigabyte. Then you have a locally traditional DIMM channels. Then there is a memory expansion. That's why I think we had this need to redefine our own nomenclature exactly what we mean by expansion, sharing, and pooling. We call this as anything which is local inside the server is remote memory local or remote memory expansion, and then the switch and fabric attached pooled and shared current on demand provisioning. Correct. So those are the typical sharing mechanisms. So I had this question mark on the CXL or CXL over some optics or Ethernet. The reason is that CXL as it is, if you want to scale to the switch side fabric, is going to be extremely challenging beyond the one chassis domain. Doing that on the rack side is going to be an extremely difficult to pull off.
Hey,
So
Anand,
those, yeah, go ahead.
I don't know whether you're, it's my side, but I see only first slide for your presentation so far.
How is it? Can you see it now
We
or
are
no?
seeing the title slide.
We are in the title slide only.
No, why is that?
Okay, now it moved. We are on the course channels
Oh,
and memory bandwidth slide.
okay. Yeah, I was referring to this one slide. Can you see it
Okay,
now?
okay, okay. Okay, now we can see it.
Okay.
Okay.
Yeah, I think when I go to the big presenter mode, something is messing it up. Okay. Anyway,
Maybe
I
it's a,
think
okay.
yeah. Yeah. So this is how I see basically the tiers 0, 1, 2, 3, and 4. So this we need to really figure it out how all these tiers fundamentally behave in all this discovery phase and the composition phase, uh, as well as the operating system. This is the main memory options we are talking about, correct? The last one could be tier 3, tier 4 could be completely non-DRAM based also. Okay. Now, why we think is that the new form factor is required. If you look at it, the cores are fundamentally quadrupling from 32 cores today to 128 and more and beyond, correct? But the channel fundamentally, which is attached to the SoC, cannot grow beyond the 12 DIMMs. So you basically get the tier which is faster, very close to it, but now it is not going to be available for you to capacity expansion. Even with the we basically will max out around 3 terabyte to 6 terabyte. Beyond 6 terabyte, the cost of the DIMM is going to be very, very expensive, and tying that memory to the server without reusing it somewhere else is going to be an extremely challenging from the cost perspective. So that's one aspect of it. The second thing is that high reliance on the high
Hey,
density. Hello. Yeah. So higher reliance on higher density will be basically extremely cost-wise expensive on the server. So we think that M8 or the next generation of the AMD CPUs, the capacity and bandwidth scaling will require a new memory IO interconnect outside of the server domain. It could be CXL, it could be anything over the CXL or something. And that requires on the external side another form factor to hold lot of memory pooling type of devices. And this is the basis for the SFFTA TA103 for that. There will be use cases where the memory capacity tier will come and migrate away from the server. And for that, we need to define a new form factor for holding 8 to 10 channels of the memory inside the new form factor. So with that, we created a new form factor of new group SFFTA 1034 to define a new pluggable multipurpose module. Initial focus was mostly on creating for the DPU and edge compute market. But later on, we said, okay, this is a fantastic opportunity to use for a CXL expansion. So a lot of this discussions which is in this group is will happen is mostly from the CXL perspective, how many channels we can expand beyond what is available on the server, and what are the bandwidth requirements for that, how do we do the bifurcation or the dynamic discovery and all of the things. So currently the Cisco, HP, and Intel are basically sponsor for this initiative. There are a lot of people joining slowly and contributing from connector side, electrical side, and on the pin list definition. So with that in mind, this is an agenda of that meeting, SFFTA 1034. Why new form factor? What are the use cases? How to define a mechanical form factor? What are the electricals, PCI Gen 5, PCI Gen 6, what are the sidebands, compatibility aspect to the existing OCP form factor, thermal power envelope, and airflow assumptions. So these are the discussions right now happening in the SFFTA 1034. Let me stop here before I go to the next slide. Do you see the need for defining a, a pooled memory form factor outside of the server side? or or inside the server which can hold lot of the memory? Is that a fundamental requirement, or the pooling is fundamentally outside the scope of the sorry the form factor definition is out of the CMS? That's the basis. I wanted to start on that.
Um, I can say what I'm thinking, but I would love to hear from everybody else. But I think for sure, hardware configuration as a hardware specification is definitely a main part of OCP contributions, and getting alignment with people is definitely something that I think we can use. So um, as the requirements may evolve, like Mahesh was beginning to talk, which we could not do today, but require for pooling may differ from system to some level, but there are going to be a lot of commonalities, I think. So to identify those commonalities and specifically coming along on the uh, definition and specification for that will help us to have maybe common requirement going for somebody people who are building the solutions. So I definitely think this is within the scope. Actual solutions, of course, we'll have to discuss as we go along, but as a fundamental requirement for getting common form factors, common solutions, and connectors defined uh, would would be a common goal, is what I think. Uh, but I would like to hear from others also.
Yeah, yeah.
Yeah,
Because the
so
reason is yeah, because we want
um,
to have a lot
Yes,
of
as Anand
cooperation between
summaries,
you guys. Yeah, go ahead.
looks like
yeah, so
Samir had
my
something.
point, Anand, I agree with both of you about this new form factor. But before we start diving into the details, I think we really need to have a debate. Is there really a need for another form factor, right?
Correct.
There is a E1, E3, and pooling multi-headed. Uh, so yeah, let's
That's
have
my
that.
next. That's my next slide. So coming up. Okay. So I just wanted to set before I dive into that why it is required for a new form factor. I I
Okay.
I'm covering exactly like that, but I just wanted to pause before people will have the same question back and forth. So I just wanted to stop here. Okay. So let me go to the next slide. Okay, so this is where we are right now, correct? If you look at the industry basically is where we are talking. There is a PCI CAM market, which is the card electromechanical, which is can get from 75 watt to 600 watt type of cable connector system, which is the standard PCI CAM, full height, full length, half height, half length. There are almost 3 to 4 different form factors there. And then on another side is a storage form factor, which is the E3, E1, and all other form factor, correct? They're all capable. They have both of them have positives and negatives on that. The AIC or PCI CAM is fundamentally has been there since the ages. The challenge is that there is no hot plug capability, thermally challenging. You basically have an asymmetric IO placement on the ASIC, higher signal loss as we go. Basically, every time the connector vendor has to really come with the ground pattern on the baseboard to really support the high speed nature. accessibility and serviceability issue results in server downtime. So if you really want to change a DIM, where you have to really power down the server and then change this one. With that, E3 basically solves a lot of the issues, and it is fundamentally limited only to 80 watt, correct? That is the challenge right now. Even the 80 watt thermal is an extremely difficult to pull off in a constrained system. So it's a smaller connection footprint, good signal, better signal loss budget, supports hot plug. The challenge is that it was designed for a multi-terabyte storage and low power NIC type of application. It was never designed from the perspective of the CXL. You are not going to basically say, hey, I just want to expand a memory of around 256 gigabyte or 1 terabyte type of thing, or 512 gigabyte of memory. You want pool to be extremely multi-terabyte type of thing, which is not possible with EDSFF. People will say that, hey, I can put more of them, correct? One or two. That basically tells, okay, that you are going to add lot of those pieces on the server side or on the front side. That means you are taking out away from the front side lot of the storage capability of that, correct? So a lot of these back and forth discussions which happen in the SNIA. And then we said, okay, hey, there is a limited memory expansion on E3. Why do you want to basically do everything on the E1 and E3? People are going to design. I'm not going to say that they are not going to design, but you cannot use a standard DIMM form factor. So every time you put E1 and E3, you have to put the chips on the baseboard to do that. So that is going to cause a lot of issues. So you cannot leverage the DIMM, which is very much standard in the server, and use it in the new form factor. That is the biggest challenge on E3 and E1. Let me pause here
So
for a
another
moment.
question.
Hmm.
Yeah. So the do we run out of the power budget beyond 1 DPC 2 channel type of DIM uh,
No,
DIMMs,
so
or
this is
when do
where,
we run out of the power budget for
yeah,
80
you
watts?
run out of the power when you want to basically go, let's say, 4 channel type of designs, correct?
4 channels, I see.
4 channel, 2 DIMMs capacity, correct? So let's say one
Mm.
DIMM is fundamentally close to 20 watt today, 25 watt on the DDR5, DDR6, and it will go to almost close to 25 within probably another 2 years. So imagine how the controller is going to be at least 5 to 10 watt for the E3 type of thing I'm talking about, correct? So you trying to expand those type of capacities inside per channel basis, a 75 watt E3 is going to be an extremely difficult from capacity perspective.
I see.
That is the point we're trying to make. Not only that, I think another challenge is basically, hey, we had to go to 4x, and the 4x capacity, which majority of the E3 today is around 4x PCI Gen 5. Okay, trying to do all those things, Gen 6 and all things. That means you are adding the cost on the controller only to support 1 channel or 2 channels. So that is another cost. From cost perspective, you get better cost per gigabyte if you really design a centralized big ASIC, 8 to 10 channel, and then let that cost amortize over that ASIC rather than having 1 channel based mm, controller design.
Yeah, I think the question is going to be, what is the smallest unit of um, memory buffer configuration? Controller plus 2 channels, or is it going to be controller plus 4 or 8? And the
Yeah,
BP as well, right? So
correct.
I mean just looking at the history of what happened with NVMe SSDs, typically it tends to be at certain the PCI lane count, and then you normally try to scale out. This
Correct.
is more of a scale up solution. Um, do you agree, or beyond the 2 channel config, or do you see that even
No,
for two
so
channels with
we
external DIMMs? Uh,
pooling and expansion has to be more of a scale out type of thing. Scale up in the sense that the scale up is more from the frequency perspective, but the capacity needs to scale out, correct? Because that means you need to have more channels, correct? Why would anybody from the cost perspective do only four DIMM expansion type of thing? You really need to see a pool fashion where I need to do multi-terabyte of expansion on the pool. Otherwise, it becomes from the server vendor. Why do I want to basically do this kind of design, correct? That's one aspect of it. to see.
Hmm.
How do you envision expanding the memory? Is it just a few megabytes or few gigabytes? Sorry, not megabyte, few gigabytes, or you are talking about a terabytes worth of expansion outside the server, or even within the inside server, locally away from the attached to the CRAM, DRAM. Oh, sorry, to the CPU. This is where, so it is a capacity and the bandwidth limitation of E3, which will limit you from going beyond certain
Yeah, that's what I'm
offerings.
trying to get to. What
Okay.
is that capacity and bandwidth,
Yeah.
barrier with C3, and when do you need to cross that?
Yeah, so capacity bandwidth, you could basically say, hey, I will pack as much as possible inside E3, and that probably would run roughly close to, in my opinion, from the high capacity around half a terabyte to 1 terabyte.
Hmm.
Yeah,
Because the
Anand,
more the more capacity you try to add on to this one, because the DRAM densities do DRAM chip densities every 2 years the node changes, correct? And the node changes, that means you are going from 24 gig to 48 gig. That will happen on every 2 year generation. And if that happens, you will be able to generate more and more capacity. The challenge is that the moment you do that, the power also goes up big time on that.
Hmm. Right.
A 16 chip solution on the E3 is extremely difficult to pull off. I mean, there are people here from Microns and all the thing, people can talk about it, but to do that
Hmm.
sort of thing is an extremely difficult to pull off. So the currently why the E3 and E1 are coming is that people think, hey, I have the already socket on the server. Can I just take the DIMM and a controller and put it there so I can create another DIMM equivalent outside of the scope, outside the area of the CPU's locality, correct? So I have a socket out there or the E3 DIMM uh, location out there, and I can put the memory there. But that's not going to work out from capacity perspective down the line.
Right. And do we have a similar issue with the multi-headed as well? Because you need to have enough number of channels and the capacity
Correct.
behind
So
it to be
this
able
is
to
my
support.
next slide. So I'll
Okay.
come back to I'll skip this one and I'll come back to this one. This is what we think the memory cassette or the CXL would look like it. Around 8 to 12 standard DIMMs. So remember here, I'm not trying to put the DIMMs on the baseboard. These DIMMs are actually, I can reuse the DIMMs which is on the server and put it on this one. So this is one of the benefit that the mass scale volume of the DIMMs, I could really reuse that on the new form factor vertically. So take the same DIMM, put it on this module, and you could actually do two ways you could do that. You could do a 4 channel and eight DIMMs, which is two DPC type of thing, so that you get a capacity tier on this one. Or you could say, hey, I don't care about the capacity tier there. I will create my controller in a fashion where I can satisfy to do as much as channel based uh, memory. That means I can design six into two channels for 12 channel DIMMs, or I can say 6 channels only or 4 channels only. So it gives an end user the ability to scale from capacity perspective or from the performance perspective.
Okay. So this is not the packaged memory, but rather pluggable DIMM
Correct, correct,
modules.
correct,
Okay.
correct.
What is the connector at the back? It's
Yeah.
EDSFF
Connector at
port.
the back is a BY32 EDSFF 4C plus 4C connector. This is the new connector which we are defining it.
Oh,
So we will leverage it from the E3 side. Yeah, E3, which was probably leveraged from Gen Z connector. Yeah.
And the
and do
DIMM
we need
slot's the same as a server board, or is it,
These
the
DIMM
DIMM
slots are
connections?
exactly same as a server board.
Same.
Yes.
Okay.
and do you think we need
This doesn't prevent from from the memory manufacturer to do a chip on the board because it's a
Hmm.
completely
Hmm.
packaged solution for you.
Hmm. Right. Yeah.
and do you think we need any modifications to the EDSFF in terms of signaling to support the memory controller, or we can just leverage whatever connectors we
Yeah,
have?
so you could basically design using the standard currently by 16, which is defined on the EDSFF E31.L, sorry, E3L, or you say I need a more IO capacity, correct? Let's say you want to go by 32 or 2 by 16 CXL channels. You should be able to handle that. That's why the new form factor has come. We are
Mm.
supporting by 32 not by 16, which is today's another E3 challenge.
And it will support up to what's the frequency? The
Yeah,
DDR
the
frequency?
frequency could be fundamentally the 64, the PCI Gen 6, it is designed with PCI Gen 6 in mind, not Gen 5.
Right,
So
right.
you could scale that. There will be always delta between the memory speed of the locally attached to the CPU versus on the CXL. That's going to happen because ultimately the bandwidth is by 32 Gen 6, correct? That is what your input bandwidth is going to look like it.
So this is
Yeah,
the,
then,
essentially you're looking at 32 lanes PCIe Gen 6.
Yep.
Anant, I
Wow.
have
Yep.
a comment here.
Hmm.
Yeah, this is good and interesting and solves the capacity problems of E1, E3. And there will be specific use cases such as SQL, which needs lots of memory. So that will benefit from that. My only concern is now this is a new type of a server motherboard where somebody has to bring out a by 32 CXL, right? So
Correct.
it's a different SKU. And
Yep.
maybe there will be some volume for that too, because currently there are these high memory count machines specifically deployed for SQL. So yeah, it's one segment which can see this type of a connector. But yeah, the others will also stay because that's a general purpose. And there is also a trend in data center to minimize the number of SKUs. So
Correct.
yeah, this may fit into one of those.
Yeah, so the idea here is basically, let's say if you have a DIM, biggest interesting thing in the current server is that let's say DIM is bad, correct? You could just swap the DIM. That's the fun, that's an idea, correct? Here also you could do the same thing. If you do a chip level stuff, you fundamentally is causing a problem to swap the E3 module or E1 module because nobody can fix that if there is a DIM channel issues on the chip itself, correct? Here you could easily swap the DIM. That's one of the other advantage of the CXL memory cassette here we're talking.
Yeah. Plus
And
controller
by the way,
cost.
this form factor is not just the memory thing. There are, I mean, I skipped a lot of the other use cases here. Basically, it is designed for the SNIC and DPU compute, high TDP GPUs, 300 watts. So we're trying to basically get the market of the PCI came market by
Mm.
using a new hot plug capability which is missing on the current PCIe and serviceability issues. Those are the two issues, and there is no form factor which exists around 350 to 400 watt which can offer you that kind of by 32 uh, IO performance from the CXL or PCI side. And then the second thing is the hot plug capability. E3 even are more on the storage side rather than on the memory side.
Yeah.
That's why there was a gap which need to be filled with the new form factor, and this is where the use case really worked out beautiful. Now interesting, another thing is that the CXL memory controller, as you said, I mean there's a lot of discussion on the IO side, performance side, how do we improve the caching capability of that. So there are a lot of solutions people are already thinking is that, hey, I don't really need to read from the DIM itself. I have enough caching capability on the CXL memory controller, and I can actually turn the transaction back much faster uh, to this host side. So this is the benefits which is going to come. The more you try to put in the E1 and E3, the ability to add the caching and all other thing is going to be extremely limited because the form factor is extremely limited for that.
Correct, correct. And if
That's what.
if my use case needs more memory, then definitely instead of having four E1 or E3, I can just have one of these and one controller cost versus four controllers in that case, right? So it's
Correct,
cheaper too.
correct,
So
correct.
yeah, advantages are there, yeah, for a specific SKU. Yeah,
No, I think the big difference is really the ability to reuse this is the external DEM,
Yep,
connectors, right? Not the typical form factors where you actually have everything within the module itself. Um,
yep,
so
yep,
it's almost
yep.
like a memory buffer, memory tray that we have been talking about, right, Manoj? This not the bandwidth and capacity, but memory tray module
Right,
stack.
right. And
Yep.
I more I look at it as well, the pooled use cases. If you had multi-headed pool use cases, which has a large capacity requirement, seems like you
Right.
and which is going to be balanced with the bandwidth too, right? This is where I think you are going to be limited otherwise at how what's the number of pins here. So the by 32 will become interesting, important. The capacity that you land, and especially if you look at the capacity that it is targeting, uh, you would need, and I think Samir's point was also like, there is going to be a use case where I want to have small capacity, but uh, sharing it across multiple pools, multiple servers. But then if I need large capacity, uh, we need something for sure. And this may be a good common way of doing it.
Correct. So this is an interesting aspect. Another thing, interesting
Yeah.
aspect which is coming here is the ability to the asymmetric or dynamic bifurcation. So you really can support multiple hosts into this one. The whole idea of
Yeah.
supporting multiple, let's say you got 4 hosts and I could actually partition 2 channels. So I, instead of by 32, I can say 1 by 8 channel of the CXL Gen 6, I can allocate to the one host, another to another host, and that sort of thing. So that is which is very, very difficult to pull off on E1 and E3 type of thing in a
Yeah.
multi-hosted. So the
Yeah.
E1 E3 will really remain very close to the server type of designs if somebody wants to do that, versus in a pooled and multi sharing or multi-host environment. I think this is fantastic opportunity to do that.
Yeah, Anand, if you can think of having, say, another 4 out-facing CXL ports on this, and then we can connect it to multiple hosts, then we can
Which is
achieve
what we
our.
support the next, yeah, which is what something called as a, I don't know. I mean, I haven't gone much detail in this one. There is a bifurcation effort of the by
Mhm.
32. So I could partition into 2 by 16, 4 by 8, or 8 by 4, or I could do two combinations of that. So the reason for that is there is a I mean, we think today is a host and endpoint thing. In a 3.0, there is not going to be host and endpoint type of thing. You could have a lot of root ports. The DPU can become a root port for that, correct? So you have peer-to-peer
Mhm.
communications. In that case, the whole definition of direction is going to be completely up to the system vendor's control. I mean, it's not
Right.
just the SOC to the end memory. There could be a memory sitting somewhere where the endpoint become root and then talk about to make an access. So a lot of asymmetric configurations will come into the picture, and that's where the E1 E3 or not even PCIe will work in the new environment.
Anand, I had a
I think,
question for you. On the previous slide, you mentioned, like, just for the math, maybe you just mentioned PCI, Gen 5, but you also mentioned Gen 6. So
Yeah,
I'm
yeah,
is
yeah.
it a Gen 6 intercept for this, or?
Yes, it is a Gen 6 intercept for this one. Yeah,
Okay, okay,
yeah.
thanks.
I'll change this one. This is very some of the slides very early onwards, so I will put that in the Gen 6 domain.
Okay, thanks.
So the fifth bullet is basically with Gen 5 interface, you could do a 4 channel at 4400. I mean, I'm just doing the translation of the DIMM bandwidth versus how much you can support, and then at 8 channel at Gen 5, which is what you could do from the bandwidth perspective, correct?
Right.
That is where, but
I was just wondering if it was illustrative as opposed to
yeah,
what the. So,
would do that, no problem.
thanks.
Yeah. And a lot of people basically are designing the controllers with a lot of smart features, which is uh, not the real caching type of thing, but frequently used data address and all other things. So you will have a lot of multi-megabyte of caching on the controller itself to hide the latency. So this is so that feature or the more cache, the more you add, the controller becomes more and more power hungry, which that's where it's hard to pull all those sorts of use cases in E1 and E3 type of thing. So this is the I think the biggest discussion right now is happening is in the bifurcation right now. I think there was a Damien from the OCP or the Meta was gone yesterday in the meeting. So we are basically doing some straw poll on what sort of bifurcation and use cases, multi-host and all other thing, you will be able to support, whether to do the static or dynamic bifurcation. So now this is something Mahesh basically brought today morning, and this is what we are trying to figure it out, is there a pre-bias configuration to the endpoint that needs to be, let's say system comes up, we power up, and that device is, let's say, is have an ability to support 8x4 and you have multi-host, how do you tell the endpoint that, hey, I want to configure you as 8x4 type of interfaces, uh, and how do we support that kind of a bifurcation and transfer that knowledge to the endpoint? And this is where a lot of discussions happening right now, so that we can say, hey, there is some programmable way to basically dynamically change the bifurcation based on the host system requirement, rather than fixing through the some kind of a pins mechanism. So this is a pre-bias or pre-bias environment through the fabric manager or the bias, the BMC management. And then once you design that, the endpoint basically reads and configures so that whenever the enumeration happens to the bias, it is ready for all this next generation, all the proper bifurcation support based on the host. So this
Yeah.
is something which I think we need to probably spend more
So
time, and I think CMS has to really see how we can do this kind of a pre-bias environment
So
also.
Anand, fundamentally, this presetting of the multi-host um, multi-host memory device need to happen before the enumeration takes place. Because
Yep,
by that time, and of course, we need to discuss how to make this from the root of
correct,
trust
correct.
partition, make sure that it is something that root of trust confirm that that this request. Yeah, we'll need to discuss it.
Yeah, so this is one of the biggest differentiation which we would like to put it onto this one, because you have at your disposal a by 32 channel and a multi-host environment. You don't want to do one configuration and done with it, correct? You should have an ability to change a
Correct.
lot of these different use cases on that.
Correct.
I have, yeah,
hey guys, I know we are a little
yeah,
over time.
Yeah. Yeah.
Anand, I
We're
think yeah.
thanks.
So we can continue discussing this next week to take the feedback from the team. What we'll do, Anand, if you can ship me, I think you have shipped me once, but if it change,
I think
if
this
you
is
can
the
send,
new one. I can send this
okay,
one.
yeah.
Yeah, yeah,
If you can
yeah.
send me that, then I will send it out. Guys, also please join email list for OCP CMS. That way, actually, when you send it out, we can have a common place. Otherwise, I'll respond for all these email for calendar right now, but we can get the content there. And we can continue to discuss this and start preparing towards what that contribution would look like, Anand. But more
Yeah.
importantly, looks like there is an alignment for a need, but we need to start bringing out what exactly would be specified, how this really correlate to the contribution that is being done in SNIA and the opens and further discussion, especially as Mahesh's presentation started. It looks like there's a lot more discussion that goes along with pooling discussion,
Yep.
especially on this configuration. So let's pick it up next week again.
I think yeah, great. I'll send out the slides. I think
Yes,
let's discuss this bifurcation, because this is fundamentally during this discovery phases where it should happen. How do we change that? This is very important aspect of
yes.
it.
Yeah.
Okay.
Yeah.
Yeah. So it's good. That's good. Hey, this is good. Thanks everybody, and sorry about the staff again today for the meeting. Let's pick it up next week. I have recorded the session. Hopefully, I'll figure out where to upload it. And then we'll continue the discussion for Mahesh's presentation and also Anand's topics for the further discussion. All right.
Right.
See you guys. Have a nice
All
day.
right. Thanks, everyone.
You
Bye.
too.
Thank you.